You can use coordinate geometry and algebra to prove theorems in geometry. This kind of proof is called a coordinate proof. Sometimes it is easier to show that a theorem is true by using a coordinate proof rather than a standard deductive proof. It is useful to write a plan for a coordinate proof. Problem 3 shows you how. Problem 3, planning a coordinate proof. Plan a coordinate proof of the trapezoid midsegment theorem, Theorem 621. 1. The midsegment of a trapezoid is parallel to the bases. 2. The length of the midsegment of a trapezoid is half the sum of the lengths of the bases. So step 1. Draw and label a figure. Midpoints will be involved, so use multiples of 2 to name coordinates. So we can see the diagram. Vertex O is placed at the origin. Vertex P is at 2a, 0. Now we could have used simply a for the x-coordinate, but since we're using midpoints, like was recommended, if we use 2a, that will make dividing by 2 simpler, and it might make our answer simplify more nicely later on. Vertex A at 2d, 2c, and vertex R at 2b, 2c. Step 2. Write the given and proof statements. We'll use the information on the diagram to write the statements. We're given that segment MN is the midsegment of trapezoid ORAP. We'll prove segment MN is parallel to segment OP, and that segment MN is parallel to segment RA, and that MN equals 1/2 of the quantity, the sum of OP and RA. Step 3. Determine the formulas you will need. Then write the plan. First, use the midpoint formula to find the coordinates of M and N. Remember, those will be the endpoints of our midsegment. Then use the slope formula to determine whether the slopes of segment MN, segment OP, and segment RA are equal. If they are, segments MN, OP, and RA are parallel. Finally, use the distance formula to compare the lengths of the segments MN, OP, and RA. Your turn. Plan a coordinate proof of the triangle midsegment theorem, Theorem 5.1.